Please welcome Franka Schmidt.
Okay, so hi everyone, thanks for the really nice introduction. So I'm Franka, really excited to be here today. It's my first conference talk, so I hope it goes well. Yeah, let's get started. So I'm going to be talking about homoiconicity, and if you're a Clojure programmer or you've spent some time around Clojure programmers, you've probably heard some of them mumble like this thing, code is data, usually followed by data as code. So I've programmed Clojure for 2 years now, and that includes like shipping production code in Clojure. And I kind of like knew what this meant, but I never really felt like I fully understand what people mean when they talk about this. And I kind of suspect that although many of you in the audience are really smart and awesome Clojure programmers, maybe some of you feel the same way. So I thought there's an opportunity here to really dig into this concept and see what we can do with it. So yeah, when people say code is data, what they actually mean is homoiconicity. So I kind of did some research on this, and as I was researching on it, I got like more and more excited. I was actually like, I think homoiconicity is Clojure's superpower. And I hope today I can convince you the same. So I'm going to start by talking a little bit about what homoiconicity is and how it works in Clojure. And then afterwards, I'm going to guide you through a series of examples that really, or projects that really showcase how homoiconicity works in Clojure. Yeah, and that's the adventure part. One more thing before I start. So like Stefan said, I'm a member of ClojureBridge in Berlin, and that's the reason I'm here really today and why I continue to, I'm so involved with Clojure in Berlin. So quick shout out to them again, support your local ClojureBridge. Another thing before I start is that there will be some like GIFs and moving images. If you're sensitive to that, look out for the hashtag Dizzy in the bottom left corner of the slide before, like on the side before the GIF. So keep that in mind. So I just made this claim like homoiconicity is Clojure's superpower. What is homoiconicity? Okay, so I started like looking at Wikipedia, of course, but then I went to the Clojure main site. So there it says Clojure is a homoiconic language, which is a fancy term describing the fact that Clojure programs are represented by Clojure data structures. It's like, okay, that kind of makes sense. So we know that the code we write in Clojure is similar or the same as what Clojure looks underneath the hood. So this word homoicon comes from Greek. Homo is the same, and icon stands for representation. I found this really useful, also just trying to remember how to spell homoiconicity, because you're like homoiconicity, okay. So what does this look like in Clojure? Let's look at this form. And when I here, +1, 2. So we know what we look at this is that we're adding 2 numbers. That's what's happening there. We're applying this plus function to the arguments. But at the same time, we also have a list of the forms 1 and 2 and plus. Another example, def time till lunch. So we have like half of this talk left, another talk, some random time you're going to be standing in the lunch queue. For me, that was 49 minutes, maybe more for you. So we defined a time left until lunch, but we also have a list of the forms def time until lunch and this whole mathematic expression where we calculate how long it's going to be. So I've said a bit about like Clojure's data and data structures. So for this to kind of understand what these data structures actually are, I want to introduce you, if you don't already know, about EDN. So EDN is kind of the set of values that Clojure knows. Some of these are really like obvious. So integers, you know, strings, you know about booleans. And then we have things like lists, vectors, and maps. So actually Clojure is a superset of EDN, but it's kind of the base. And it's the same values are used for example, datomic. And it's not sort of married to Clojure. Technically, you could use EDN for other languages as well. So Clojure programmers or Clojure programs, not programmers, are represented in a superset, maybe also Clojure programmers, who knows, of EDN. And Clojure programs handle data that is a superset of EDN. So if we go back to this homo icon same representation, that's what people talk about when they talk about the same representation, or code is data and data is code. And what that gives us is that it's really easy to write, manipulate, and reason about Clojure programs in Clojure. And that's kind of sort of the starting point for my exploration here. So I quickly want to talk about quote and eval, because I found these to be some really useful tools to understand homoiconicity. So what quote does is to tell the compiler, please treat a form as data, not as code in this time. So when you normally type +15 into your REPL, it will be evaluated. That's where the E in REPL comes from. You will get the result 6. But when you call the quote function on it first, it will return to you the form that you gave it. So in that case, it was treated as data, which means that we don't manipulate it like we would, for example, with a primitive data type, like if you would give it a string, if you would type a string into the REPL, it would just give you back the same string. A shortcut for quote is the single quote that you will see me using throughout this presentation. Eval is kind of the other side of that same coin. So, like I said, when you type something into the REPL, it always evaluates it immediately, so you don't need to actually type the eval function. However, so let's go back to the expression we saw before, the quoted one. If we were to call eval on that explicitly, then we would go back to the actual eval expression. And it's between, so this is kind of obvious, like you're going back and forth between data and code. But it's kind of in the space between these two things where the interesting things happen. So where you can start looking at delayed evaluation, or deciding when to treat a form as either data to be evaluated later, or code that you want to run right now. So Clojure programmers are pretty good at handling data. Like, it's kind of what we do very often. So what are the things we can do with data? We can visualize it, analyze it, generate it. Probably some more things. Those are the ones I'm focusing on right now. So if code is data, or can be represented as data, can we visualize our code, analyze our code, and generate more code? Let's see. So part 1, visualize yourself. So this is a small project I did, teaching a program to visualize stats about itself. So you can look the code up on GitHub. But the idea here is that I wanted to see, can I make like a small program, and it's a sketch in Quill. And then while you're kind of developing the program or typing code, can you make it show you things about itself? So this is what the sketch looks like. It's a little Quill sketch. Quill is a wrapper a Clojure wrapper around processing, and it basically just draws some dots and like looks nice. And so the interesting part that we're going to be looking at is that I want the background of this sketch to change as I'm developing my code. And so I thought, okay, like visualize yourself. We're going to start by something simple. So I wanted to find a simple metric that would tell me some things about my progress while writing this code. I was like, okay, why don't I start with the number of definitions I have in a namespace? That's like a simple thing we can count, and it's easy to understand. And then we can visualize it. So if you see here, let's go back to this project. At the top, we have this little status bar, and it tells us some things about what's happening. So we have currently 8 public definitions in this namespace. 51 is the current color, so it's between 0 and 255 because it's a black and white thingy. And visualize code.core is the current namespace. Okay, so you can, I hope you can see how the background changes in the next slide. If not, then you can have a look at the status bar to see, yeah, the text of it. So, okay, so here you have like me typing code. I'm just uncommenting here, but the idea is if you would be like adding new things. And at the same time, like the background of the other thing is changing. And I was like, oh, this is really cool. Like I can make my project that I'm working on show things about itself and also visualize it. I was pretty happy with this. So yeah, you see the background is changing and the numbers at the top are changing as well. So in the code, you need to go into the namespace that you're working in your REPL, with require and in the namespace. And then you have this star or asterisk ns thing which shows you the current namespace that the code is executing in. So it says here, it's an object, blah, 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 visualize code.core, which you also get when you call the string function on it. And so once you have that, so once you can say, I have my current namespace, you can call, there's a variety of functions that Clojure supplies us with to get some information about this current namespace we're working with. The one I decided to use for this is ns_publics, which gives you a sequence of all the public defs in the namespace. And then you can call keys. So in the quill sketch itself, I get the current namespace. And then in my draw function, I use this ns_publics function to get the current number of current defs in this namespace. And then I calculate a color based on some transformation in that number to get it to be between 0 and 255, which I can then use as a color code. Other interesting functions you could use for namespace, like evaluation, include ns_refers, aliases, ns_interns. And of course, you can also go like a completely different direction. This was like an easy, nice way to start. But you could also think about visualizing your abstract syntax tree in a more sophisticated way. So the takeaways from this, for me, were that it was super easy for my Clojure program to read other Clojure programs in this case itself. And like while the project was even running, I could use the way that it's changing as I was typing more code to visualize it, which was cool. And then once you have some kind of data about your code, or your code is data, you can visualize it trivially with various tools. Okay, part 2, dev tooling. So I was researching more things people have said, thought, and done with and about homoiconicity, and I stumbled upon this quote. One thing I really appreciate with code is data in a language such as Clojure is the power of your editor. The power of an editor is related to how well it can interact and analyze code. And that's by Joseph Wilk, who's done some really cool live coding Clojure stuff with Overtone. And I was like, actually, this makes a lot of sense. So the reason that why our dev tooling in Clojure is so cool with live coding, interactive coding, as I just showed it before, having the REPL, etc., is because it's really easy for Clojure programs to analyze the code that you're typing as you're developing in your development environment. And for me, I was like, a huge part of why I appreciate Clojure is because the dev tools are so cool, and like interacting with the REPL is really fun. It's like, oh, okay, I didn't realize that homoiconicity has a really great role here as well. So yeah, these are the things that it gives you. Yeah, so that was kind of I hadn't thought about it this way before, so I thought that was a really great point to take away. So yeah, homoiconicity is the base for awesome dev tooling, I think, in Clojure. Part 3, what about macros? So maybe this is the questions that's been sitting like at the back of some of your minds since I started talking about homoiconicity. So yes, homoiconicity is what allows us to use and write macros in Clojure. So if you don't know, a macro is a way to extend a language by creating new constructs the compiler understands. Turns out, even if you don't write your own macros, you've probably used a lot of Clojure macros before. They're actually very common in everyday Clojure programming, and you don't often realize when you're writing a macro or using it. For example, or, and, when are examples of macros that are really commonly used. OK, so let's look at one macro and see how it kind of works. So I used when. I defined n as 42, and I had this little thing said when n is even, say to me n is an even number and return n. And it works as you expected it to. It says n is an even number, returns 42. And then we rebind n to a different number, and we get no back because we didn't say what we, well, yeah, because it's not even. OK, so I like heard then as a macro. Turns out there's a really cool tool to, when you're writing macros or interacting with them or using them as edit here, find out more about how they work. Macro expand. So I can call macro expand on this whole form that I typed earlier, and it will give me back exactly the expanded expression of what I typed in before. So it says if n is even, do print line n is an even number and return n. And I thought that was really cool that you're just giving it this expression and then it gives you back exactly what it is kind of under the hood. You also notice here that the quote operator that I mentioned earlier appears. And that is because this is a great example of when we want to treat code as data, because we want to give this form that we defined as a data as an input into macro expand. We wanted to tell us something about this code without evaluating it. We just want to know more information about it. So what were to happen if we didn't do that? If we just said macro expand, blah, 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 well, it wouldn't give us anything useful because it would evaluate it going back to here to say it just returns 42. And then we'd call macro expand on 42, which is just 42 because it's just 42. OK, let's look at a different one. So if not is another nice example. If not even 41, it's not an even number. If you call macro expand on it, you can see that it's actually just if not. So it just gives you a nice shortcut there. And I thought that was interesting to see how easy it is to treat the code as data there and then get more information about the code, which you can reuse. So, like, small imposter confession, I've programmed Clojure for 2 years and I've not written a macro. Probably should have done so as preparation of this talk, but I didn't. And I suspect maybe some of you haven't either, or I've talked with some Clojure friends who are really smart programmers and they said things like, I wrote one 3 years ago and then never again since then. So I thought, like maybe we're not writing macros as much. So since maybe Clojure doesn't entirely encourage us to do so. And so I just thought, like, yes, it's a part of homoiconicity. And it's often the part that people think about first when they think about homoiconicity in Clojure. And I wanted to stress that it's an important part, but not the beginning and end all of it. So yeah, it allows us to extend the language by writing macros. Turns out Clojure programmers don't write macros that often. Or if you do, like, tell me otherwise. OK, next project. The 3G Me bot by Roger Allen. So this is a project that I found when I was first researching how to visualize code or how to do generative art in Quill, in Clojure, for our ClojureBridge study group. And Roger Allen I stumbled upon because he's done some really cool different generative art projects in Clojure. So he has this Twitter bot, 3GMe, that you can see at twitter.com/3GMe. And what it does is generate images and tweet them there. And then you can interact with the bot by liking or retweeting the images, and it will generate new images based on that input. So this is what an example tweet looks like. You get the image that was actually generated, and some data, some hashtags. OK. So if we look at, or if we click on this guest link and we look at what this image shows us, we get to something that looks like this. So there's a file name and some other meta information about the image. What I found most interestingly there is that there's this code key in the map. And then the code there is actually the entire code that it takes to make this image. So there's kind of two things happening here. So first one is that these images are, or to get to an image, it's not just sort of written code that's generating random images, but also the code itself, which generates these images, is randomly, more or less randomly generated with input from the tweets and likes, as I mentioned before. So that's the first interesting bit, is that we can, turns out there's some code generation here based on inputs, which is really cool. Second part is that we have this code here, and it's really given to us just as a data property of this map. It's like one property of this image is that it happens to be generated by this piece of code. Okay, so let's try that. We can throw this whole thing in a def, and again we get the little quote operator because we don't want to evaluate this just yet. We want to kind of save it and use it later. So we just say that the data, which happens to be code of this image, is all of this stuff that we copied from the gist. And then we call show eval code, at which point we actually evaluate the code and give it some parameters for how we want to display it. And then we get the same image, which, yeah, I think is super cool that you just have this code. And these images aren't stored anywhere. Like all they save is like the code to generate it. Yeah, so that kind of shows that we can really share, store, and reproduce these kind of results easily because we have the code and then we just evaluate it again at some later point, since code is data. We can also generate it like Roger Allen did for his image generation code through this kind of generative programming. And it's really cool for generative art. Yeah. So ClojureSpec. So ClojureSpec, most of you probably know this, but will be introduced as part of Clojure 9. And let's just do things that are really closely related to what I've been talking about for the rest of this talk. So we can describe data using specs. We can then validate data against these specs to see if the data set that we have matches the spec or not. And finally, once we have a spec, we can also generate more data that complies to the spec that we generated. So a project that uses this ClojureSpec to do interesting things in the realm of homoiconicity is Self-Healing Code by Karen Meyer. So this is a talk she gave at Euroclojure in October. I highly recommend watching it if you have not done so. Basically, she combined generative programming and using ClojureSpec to do a project Self-Healing Code. And you can see the code on this GitHub link. So Karen introduced us to this concept called CodePhage, Horizontal Code Transfer System. Fixes software errors by transferring correct code from a set of donor applications. So the basic idea here is that if you have a bug, exception, some kind of weak spot in your code, you can take code or you can take a patch from another system or from another part of your system, transfer it onto the broken spot in your code, and therefore fix the error, which is like very cool and very futuristic sounding to me, but let's have a closer look. So she had a function called average with a vector and calculating an average of a couple of numbers. And it expects as you would behave it to giving 2 or 3, depending on what the average is. But then when we give it the empty vector, that's our weak spot, and we get an exception because we didn't prepare for the divide by 0 error, which would happen when we divide by the length of the vector, which is 0 here. So that's the weak spot we want to fix. So I'm going to summarize the process that Karen had for fixing this issue, the self-healing process. So first we need to recognize that a failure occurred in order to be doing anything. If we don't know that something's wrong, then yeah, we can't do anything. Next, we need to detect where this failure actually comes from. So if we have a project, we need to see sort of where did the exception first occur, or yeah, which function kind of gave the error. The next we have, so we already have, we want to pick code from a project that we already have. So we need to pick the best patch from a given selection that matches the outputs or generates similar output to the function that we want to fix. So we need to pick the best one to do so. And finally, we need to replace the failing function with the patch. Yeah, that is what she did, exactly. So what this ends up looking like is kind of like this. So again, healing, we call this healing with healing function and wrap it around the original calc average, get back 3. And then when we call the same with the broken input before, the empty vector, we get 0. Success. So yeah, I thought this was like amazing. It's kind of, so like she kind of uses homoiconicity in a variety of ways there, both by sort of generating inputs, seeing if, like validating the potential patches to see which gives us the same input as the original functions, and then also the actual replacing the function. You can of course only do because you can take a patch of code and yeah, and replace it with something else. So that's very cool. Clojure is a great language for creating terrifying robots. I thought when I first saw this project. Not, well, kind of true, but we're not going to talk about that today. But really, for me, the main takeaway from this was that clojure.spec emphasizes and enhances like what homoiconicity already gives us in Clojure. Just makes it a lot easier to do these things that I talked about, like generating specs, makes it easier to generate data and code. Okay, let's summarize. Homoiconicity in Clojure gives us. It allows us to extend our language with macros and DSLs. It allows us to analyze our code really well, which grants for having a really powerful development tools. And yeah, we can generate code, which allows for things like mutation testing or generative programming, like we saw in Roger Allen's project. We can visualize code. For now, that was kind of just used for art project, but those might also become part of the new dev tooling in the future. And probably many more cool things. I'm sure there are loads of things that I didn't include here because it's really fundamental to the structure of our language and therefore allows for cool things. So I hope I convinced you that homoiconicity is Clojure's superpower. I'm convinced. So thank you. The slides you can find there. You can talk to me, email me, and enjoy the rest of your conference day.
There's so many faces, there's probably questions. If not, there's one. Hang on.
Hey, so with what you did for a program that understands itself or is giving some feedback, I find that to be really useful, especially for newcomers or when you're just trying to understand what it is you're doing or how it's failing or how it's succeeding. Have you done that a lot? I'm just curious if you have more thoughts about that or if some successes that you've had.
Actually, no, but I really want to. Like when I was doing that, I thought it was a really great tool. And kind of when you're working with visualizations, I guess you already have that instant feedback in many ways. But yeah, it'd be super interesting to see how that applies to programming other applications.
No more questions? Then thank you.